When you get dizzy, you feel like the earth is moving underneath you, but it actually does that. Sometimes when you're not feeling dizzy, and that's called an earthquake, it can be a weak one or strong one, which can cause huge destruction. Let's know more about how this happens in today's this video. Earthquake. Any sudden shaking of the ground caused by the passage of seismic waves through Earth's rocks. Seismic waves are produced when some form of energy stored in Earth's crust is suddenly released. Usually when masses of rock straining against one another suddenly fracture and slip.
Earthquakes occur most often along geologic faults.
Narrow zones where rock masses move in relation to one another. The major fault lines of the world are located at the fringes of the huge tectonic plates that make up Earth's crust. Little was understood about earthquakes until the emergence of seismology at the beginning of the 20th century. Seismology, which involves the scientific study of all aspects of earthquakes, has yielded answers to such long-standing questions as why and how earthquakes occur. About 50,000 earthquakes large enough to be noticed without the aid of instruments occur annually, over the entire Earth. Of these, approximately 100 are of sufficient size to produce substantial damage if their centers are near areas of habitation. Very great earthquakes occur on average about once per year. Over the centuries they have been responsible for millions of deaths and an incalculable amount of damage to property. Earth's major earthquakes occur mainly in belts coinciding with the margins of tectonic plates. This has long been apparent from early catalogues of felt earthquakes and is even more readily
discernible in modern seismicity maps, which show instrumentally determined epicenters.
The most important earthquake belt is the Circum-Pacific Belt, which affects many populated coastal regions around the Pacific Ocean. For example, those of New Zealand, New Guinea, Japan, the Aleutian Islands, Alaska, and the western coasts of North and South America. It is estimated that 80% of the energy presently released in earthquakes comes from those
whose epicenters are in this belt.
The seismic activity is by no means uniform throughout the belt, and there are a number of branches at various points. Because at many places the Circum-Pacific Belt is associated with volcanic activity, it has been popularly dubbed the Pacific Ring of Fire. A second belt, known as the Alpide Belt, passes through the Mediterranean region eastward through Asia and joins the Circum-Pacific Belt in the East Indies. The energy released in earthquakes from this belt is about 15% of the world total. They also are striking connected belts of seismic activity, mainly along oceanic ridges, including those in the Arctic Ocean, the Atlantic Ocean, and the Western Indian Ocean, and along the rift valleys of East Africa. This global seismicity distribution is best understood in terms of its plate tectonic setting. The energy can be released by elastic strain, gravity, chemical reactions, or even the earthquakes are caused by the sudden release of energy within some limited region of the rocks of
the Earth.
The energy can be released by elastic strain, gravity, chemical reactions, or even the motion of massive bodies. Of all these, the release of elastic strain is the most important cause, because this form of energy is the only kind that can be stored in sufficient quantity in the Earth to produce major disturbances. Earthquakes associated with this type of energy release are called tectonic earthquakes. Tectonic earthquakes are explained by the so-called elastic rebound theory, formulated by the American geologist Harry Fielding Reid after the San Andreas Fault ruptured in 1906, generating the Great San Francisco earthquake. According to the theory,
a tectonic earthquake occurs when strains in rock masses have accumulated to a point where the
resulting stresses exceed the strength of the rocks, and sudden fracturing results. The fractures propagate rapidly through the rock,
usually tending in the same direction and sometimes extending many kilometers along a local zone of
weakness. In 1906, for instance, the San Andreas Fault slipped along a plain 430 kilometers, 270 miles long. Along this line the ground was displaced horizontally as much as 6 meters,
20 feet.
as a fault rupture progresses along or up the fault. Rock masses are flung in opposite directions and thus spring back to a position where there is less strain. At any one point this movement may take place not at once but rather in irregular steps. These sudden slowings and restartings give rise to the vibrations that propagate as seismic waves. Such irregular properties of fault rupture are now included in the modeling of earthquake sources, both physically and mathematically. Roughnesses along the fault are referred to as asperities.
And places where the rupture slows or stops are said to be fault barriers.
Fault rupture starts at the earthquake focus, a spot that in many cases is close to 5 to 15 km under the surface. The rupture propagates in one or both directions over the fault plane until stopped or slowed at a barrier. Sometimes, instead of being stopped at the barrier, the fault rupture recommences on the far side. At other times the stresses in the rocks break the barrier, and the rupture continues.